This is Algebra 2, looking at Lesson 1.6, just a review from Algebra 1 of linear inequalities. First thing's the definition of an inequality with one variable, like x or y in this case. It doesn't have both of them. It's not a straight line. It's not something where we have to shade one side of a line. It's something simply that you can graph it on a number line, like x is greater than 3 in this case. It'd be an open bubble going that way. Anytime it's one variable, just graph it on a number line. It doesn't matter what the variable is you're talking about. But in one variable, just not two different ones, not x and y, just one or the other. A solution is any value that makes it true. So if I take the same one, x is greater than 3 that I said a second ago, a solution would be anything that fell in this area right here. Anything that's greater than 3, not counting 3 in this case. All this area this way would make it not true. So that means that wouldn't be a solution. So anything over there is a solution. A graph of an inequality is what I just showed you a couple times just now. X is greater than 3. It's just a visual representation of everything that is. This is the graph of it, the actual picture of what's going on. In Algebra 1, again, you learned how to graph inequalities that looked like this, where you graphed an equation on a Cartesian plane, like some of them with dashed lines, some of them with solid lines, and remember they were shaded one direction. Some of this is starting to come back to you. What we're going to do in this class is we're going to take lines that are not straight. We're going to take curved lines and do the same thing. But it's just as easy. It's just graphing a curved line. It's actually, once people kind of understand it, they think it's a little simpler than the straight lines, other than the fact that it gets a little messy. A compound inequality has and or in it. Or doesn't mean you choose one or the other. It's both of them at the same time. Typically, an and inequality, when you graph it, it'll be overlapping. Like this one will go this way, and this one will go this way. So they'll have this overlapping area here. Typically, not all the time. An or inequality typically will go out each direction. So you'll have one going this way and the other one going this way. Again, that's typical. Sometimes they'll both go the same way and there'll be an overlapping area, but this is typically what and or inequalities look like. Transformations that produce equivalent inequalities. Same thing, just like equations. You undo your order of operations backwards. You add and subtract the same number on both sides. This isn't order of operations. It's just telling you the transformations. But if we were looking at it as order of operations, that'd be the Aunt Sally part, the part you undo first. You do it on the same side. Then you multiply and divide the same positive number. Notice how it says positive number here. The reason that it specifies positive numbers here is because this is the only difference with inequalities versus equations. Anytime you multiply or divide both sides by a negative number, you're going to reverse the inequality, and that's what it says here. Anytime you multiply or divide by a negative number, you reverse the inequality. That is the only time you reverse it. Typically, for most people, it is easier to graph inequalities if you put the variable first. X is greater than 3. However, if you don't have any problem reading this way, if the 3 is first and the x is second, if you don't have any problem reading this as x is greater than 3, you don't have to rewrite it. Most people are okay by the time they get to Algebra 2. Okay, I know I got to read it from the variable. Instead of reading it left to right, I'll read it right to left. Most people are okay with that. But again, it makes it easier to graph if the variable's first, so just reverse it if you have to. Here's example number 1, solving an inequality with a variable on one side. It's just like an equation, 5x plus 7. Picture as if it said equals negative 3, and you do the same thing you would do. Undo plus 7 by subtracting it on both sides. That gives you 5x is greater than negative 10. And then undo 5 times x by dividing by 5 on both sides. Now, here's where the question comes up. Well, the number is negative, so do I reverse the symbol or not? This is the answer to that question. What do you divide each side by? If you divide by a positive number, in this case, we're dividing by a positive 5, you do not reverse it. It doesn't matter that the number comes out to be negative. It's what do you divide by? Since we didn't divide by a negative number, we leave the symbol alone. X is greater than negative 2. And notice it's an open bubble, and it's shading everything to the right. When you get to the next math class, You'll stop. There's open and closed bubble stuff for the most part. Just want to give y'all a heads up on it. You'll see something that looks like this. An open bubble will show a parentheses and everything that way. So if you see that, don't freak out. That just means don't count the number, -2. If it were to count the number, it would be a bracket instead of a parentheses. Okay, on the back, solve and graph this one real quick. It should only take you a minute. Okay, we got two steps here. As if it said equals in the middle, we still want to get y by itself. The reason I don't write y is greater than or y is equals because it might flip. We still want to get y by itself, though. So you undo your order of operations backwards. You do any subtraction and addition first. We have -9, so you undo -9 by adding on both sides. That leaves you with 11y on the left. 13 plus 9 is going to be 22. Now, you have to always ask yourself the question when you're doing inequalities, did I multiply or divide both sides by a negative number? If you ever answer yes, you have to reverse the inequality. All we did was add right here, so we didn't do anything to reverse it, so we're going to leave it just like it is. Then it says 11 times y. Undo that by dividing by 11. We do it to one side, do it to the other side. 22 divided by 11 is 2. Again, same question. Did I multiply or divide by a negative number on both sides? I get the answer no. So the symbol is going to stay just like it is. So y is greater than -2. When you graph it, I'm sorry, than 2. When you graph it, you don't have to put a whole bunch of tick marks and all. Just do yourself a favor and show 2 as a positive number. Put it on the right side of 0. So if you didn't put 0, just add it in. You don't have to draw another graph. And then it's greater than 2. It's not or equal to, so we have an open bubble, and it'll be everything greater than everything to the right. If that's confusing to you, look at it. This is pointing this direction, and that's the direction we're shading, that direction. That's what I meant earlier when I said it's easier to graph them if your variables first, because if your variables first, it'll always go in the same direction. Here's example number 2, variables on both sides. This is where it started to get a little tricky in Algebra 1 when you just had equations, because now you got to move your variables to one side. Nothing's changing with that. So the first thing we want to do is we want to collect all of our variables on one side. Now, when you look at this equation just like this, if it said equals in the middle, you probably would bring 2x over to the right, most of y'all. It's okay if you don't. But the reason we're bringing 3x over to the left is what I said a minute ago. It's easier if your variables are on the left to graph it. So when you subtract 3x on both sides, it leaves you with -x on the left. You still have -2 there. And then you still have 1 on the right. All we did was subtract 3x. Notice that's why the symbol does not reverse. We do not change less than or equal to greater than or equal to. From there, undo -2 on both sides by adding 2 to both sides. When you add 2 on the left, it cancels out. When you add 2 to the right, 1 plus 2 gives you 3. We still don't have x by itself, though. We have -x or -1 times x. We didn't reverse the symbol on that last step because all we did was added 2. From here, though, this is where we have to look at it. It says -1 times x is less than or equal to 3. We undo that by dividing by -1. That's how we get x by itself. When you do it to the left, do it to the right. This leaves you with x. 3 divided by -1 is -3. Now we divided both sides by a negative value, and when you do that, you reverse that symbol. From less than or equal to, it becomes greater than or equal to. So the solutions are every real number that is negative 3 or greater, or everything greater than or equal to negative 3. Okay, on the side, do this one. 7x plus 9 is greater than or equal to 10x minus 12. Take about a minute before we run out of time. Okay, again, we want to get x by itself. We have variables on both sides. It's probably easier to have the variable on the left. So that being said, instead of bringing the 7x over to the 10x, let's bring the 10x over to the 7. It's positive 10x. So in order to undo that, you subtract it. If you do it to the right, subtract 10x on the left. 7 minus 10 is negative 3x. We still have plus 9 on the left. We still have negative 12 on the right. 10x is gone. All we did was subtract 10x. We did not multiply or divide by a negative number. So this symbol is going to stay just like it is. Then we want to move the positive 9 to the other side. It's plus 9, so subtract it. Do it here. Negative 12 minus 9 is negative 21. So we have negative 3x on the left. 9 is gone. All we did again was subtract 9. So your symbol doesn't reverse. One more thing we got to do to get x by itself, divide to cancel out negative 3 times it. Divide by negative 3. You do it to the left, do the same to the right. A negative divided by negative is a positive, and we divided both sides by a negative value. So this symbol has to reverse and become less than or equal to 7. So here is it solved. When you graph it, again, just its relation to 0, it's positive. Less than or equal to means you color it in. Everything this direction would be the graph.